The main point that I've wanted you to understand is that a single photon fractalized into the whole universe, and that is no longer a suspected thing. Here's the proof once again. These two guys from Caltech saw this image, which is the amplituhedron, they call it. It's 3 tetrahedrons put together, and the big aha for me was realizing how beautifully it represents geometrically one of 4 Tinker Toy building blocks that you can fit together to build the Merkaba. Now, they probably could have calculated it out to get the whole Merkaba, but they just didn't take the time, or they didn't need to. And on July 20th of 2016, Radek Tropkiewicz used all these interesting intersecting lasers to come up with this really remarkable breakthrough that proves the point that there is a photon that is that same shape as these guys just discovered is the source of the universe. He's already become a postdoctoral research fellow at Stanford, and this is the core of his experiment. He's got 2 beams that are shooting, and there you see, as I said, on the top right, the little diamond-shaped image of a photon. Notice it's made of straight vertical lines, which indicates that they think it's a wave. They don't really see that it's a geometry. And it goes through all these mirrors and beam splitters to form an intersection pattern, which you can see there as it hits that last cube on the left. Notice that the left side has a beam that breaks off into a Y shape. Those are the 2 beams intersecting and becoming 2 separate sources that then collide together to make that hologram, which they're showing as this fiery shape. And when they tried to photograph this intersected, collapsed photon, they got this remarkable image, the Maltese cross. Now, nobody's really talking about the fact that the Schrodinger's equation on the right theoretically predicted that that's what it should look like. And then they actually proved it. So this is a monumental discovery. And again, all you got to do is pop your Merkaba over the top of that thing, and you've got it. It's very clearly a Merkaba. There's no denying that that's what we're looking at here. I didn't quite have the right way to tilt the Merkaba so you can really see it, but this is very clearly an intersection of tetrahedrons all fitting together geometrically. So I'm just going to give you a little bit of, not the whole excerpt, just a little bit, which was the quote from that Cosmos journal that I just showed you, where they performed a simple experiment to view something incredibly difficult to see, the shape and wavefronts of a single photon, according to Radoslaw Tropkiewicz. I better start learning how to pronounce that. I think I've got it. In this write-up, we see that the Polish team's experiment hinged on measuring which path each of these 2 photons from the split beams took. Depends on the shape of their wave functions. For a photon on its own, each path is equally probable, but when 2 photons approach, they interact and these odds change. And they realized that if they knew the wave function of one of the photons, they could figure out the shape of the second from the positions of flashes appearing on a detector. So as we said in the last episode, it's the intersection of these waves, it's the collapsing of the waveform, which is when it goes from being a wave to acting like a particle. And it's only once it acts like a particle in this wave-particle duality that photons have that it actually gives off visible light. When it's in a wave, it's not really detectable. And it's only when it crunches that you now have visible light coming off. I compared this in the last episode to sonoluminescence, a little bubble of gas in the middle of a sphere of water, and you hit it with sound and the bubble collapses and light comes out. And that light is unknown to mainstream science because the amount of energy that should be necessary to make that light is much greater than the amount of power of the sound that's causing it. So when we take this elongated 2 tetrahedron shape and crunch it together, as I said in previous episodes, that's where you get your Merkaba. That's where the wave becomes a particle. It flips from wave to particle. And now you're getting this very interesting shape that they discern. So let's go back and finish reading this. It's a little like firing 2 bullets to glance off of one another in midair and then using their deflected trajectories to figure our shape of each particle, which would obviously be very hard to do. That's why they're saying this was a very difficult experiment, getting 2 bullets to actually hit each other in space. Each run of the experiment produced 2 flashes on a detector, 1 for each photon. After more than 2,000 repetitions of the same thing, so they did this a bunch of times, a pattern of flashes built up. So they didn't always see the actual Maltese cross shape. They had to do it over more than 2,000 times, and they'd catch little bits of this geometric shape, because you don't always get the whole thing giving off light. That pattern of flashes built up, and then they could reconstruct the shape of the unknown photon and see